Werte Kolleginnen, werte Kollegen, sehr geehrte Gäste, ich darf Sie herzlich zum 33. Epilog der Fakultät für Informatik begrüßen. Wie immer werden wir dieses Event auf Englisch abhalten, die Lingua Franca der Wissenschaft. Dementsprechend geht es jetzt auf Englisch weiter. Dear colleagues, dear guests, a very warm welcome to the 33rd edition of the Epilog, an event of the Faculty of Informatics at TU Wien. My name is Stefan Woltran. I will be your host today and guide you through an exciting program that we have prepared for this evening. So, as some of you know, in the last 2 years, we have seen several formats for this event, and now it is for the second time a full online event, which, as you can imagine, requires a lot of synchronization between the different participants, the different speakers, and so on. So I hope for your understanding, if not all transitions will be 100% smooth. So in fact, the first challenge for me now is, in this respect, is to hand over to our welcome addresses, where we have Gerti Kappel, our dean, and not yet our rector, Sabine Seidler, because she's still in an assembly meeting of UNICO, being the head of all the universities in Austria. Of course, this is something which is slightly more important than the Epilog. Nonetheless, I will now give the word to our dean, Gerti Kappel.
Thank you, Stefan. But you can be ensured, as I know our rector, she would have preferred to be here and not being with all these alpha animals in the other meeting. Dear colleagues, dear nominated students for the Distinguished Young Alumn Award, dear representatives of Siemens Austria, Mr. Michael Freyny, Head of Digital Industries for Austria and Central and Eastern Europe, Mrs. Daniela Borgmann, our keynote speaker of today, and project lead in Digital Industries Innovation Labs at Siemens Austria, dear colleagues and dear students. As Stefan has already mentioned, we all would have liked to come together in a lecture hall and celebrate our bright minds. But nevertheless, we still defy and will always defy the pandemic, and we come at least together here in this virtual room. You know, with the Epilog, the Faculty of Informatics at TU Wien demonstrates its lasting excellence throughout the whole Bachelor and Master curriculum, starting with the Bachelor with Honors, the Siemens Excellence Awards for our female students, up to the Young Distinguished Alumn Award for our best graduate students. Of course, we try to deliver excellence on all levels, the teaching level and the research level, and try to give our best for all our students. And we have really very, very good students throughout the whole program. But it is particularly kind of an honor for me as a dean that two times a year to especially honor the best of the best. And as Georg Gottlob has put it once, the best of the best of the Faculty of Informatics can and will be the best also in other schools, be it in Cambridge, in Oxford, at MIT or somewhere else. So with not further ado, I'm really looking forward to all your presentations, and be assured, I'm pretty sure that in summer we can again reunite. You all will be invited to our next garden party with live music, with food, and then we can talk about what we have heard today. Thank you, and I'm looking forward to your presentations.
So thank you very much, Dean Kappel, for this nice welcome address. So now I'm back in the picture. Okay, so is the rector not here yet, I assume? Otherwise you will let me know. So let's continue in the program. So Douglas Rushkoff, who is an American media theorist, so he said in connection with social media the following sentence: computers have learned more about us than we've learned about them. Okay, but today we want to demonstrate the opposite, namely that our master students have learned a lot about computers and informatics in general. And we will therefore award excellent students at different stages of their academic career path, as Gerti has already announced. So first and most foremost, we have the Distinguished Young Alumn Award for excellent master thesis. Let me briefly explain the procedure here. So each research unit of our faculty can nominate at most one thesis. Then there is a jury who evaluates the thesis, and among the submitted theses selects the best 4 candidates for the presentation today. So all who made it to today's Epilog have gone through a selection process. So we are really, we can expect excellent theses here. So talking about the jury, let me briefly introduce the jury. So this is always in the last years chaired by Margrit Gelautz, and she will be accompanied by Andi Steininger, Yihua Chen, Renata Raidu, and Thomas Gärtner this time. So thanks to all of you for taking this job, this interesting job, which is, as I know from experience, not an easy job, because you need to select then a winner. So what are the rules? For each of the 4 candidates, we have reserved 15 minutes in total, which means they have 10 minutes for their presentation. And we have 5 minutes for the question and answering session, where it's mainly the jury who will ask questions, but all participants in Zoom have the opportunity to also put questions into the chat. Although I cannot promise that we, in the interest of time, that we can ask them. I will, if there is time, I will select such a question from the chat. But if not, please understand that in order to have that is fixed format for each of the candidates, that it might also well be the case that we have to ignore your question. 2 final remarks. So what is also communicated to the students before is if we have to face longer and serious connection problems during your presentation, you will be disqualified. So we hope that everything runs well. And as a final remark, the 4 candidates will present their thesis in alphabetical order. So there's no particular semantics behind the order. All right, so I think this is what I wanted to say here. And let me introduce, and I will then stop sharing, and the candidate then can start sharing immediately. So let me introduce the first candidate. So this is Axel Brumbauer, supervised by Radu Grozo, and his thesis is entitled Model-Based Reinforcement Learning for Autonomous Racing. And Axel, the floor is yours.
Hello, can you hear me?
Perfect.
Okay, I will share my screen. I hope you can see it.
Yes, also this looks good. Maybe full screen?
Yeah. Okay.
All right, so the clock is running.
Okay, fine. Welcome to my presentation about model-based reinforcement learning for autonomous racing. First of all, what is reinforcement learning? Reinforcement learning is a way to teach agents to follow an optimal behavior while interacting with a world or its environment. This happens in a way that agents first sense the state via sensors, for instance, or cameras, something like that. And then, according to some policy pi, which can be any function, compute an action that it issues to their environment. Additionally, agents observe a reward, RT, and throughout the learning process, it tries to optimize the reward or to maximize the reward it experiences throughout their interaction with the world. the dynamics of the world are usually governed by some function, which is conditioned on a state ST and the action taken by the agent. In reinforcement learning, we distinguish two families of algorithms. The first are model-free algorithms, which do not have access to this model. So they just try to optimize this policy, pi, based on the data they gather while interacting with the environment. In contrast, model-based reinforcement learning algorithms have access to some model. In simple cases like games, like chess or Go, this model is known, but in most robotic tasks, it is not. But it can be learned from data. And this is what we do in our work. But first, what are the problems of reinforcement learning agents or algorithms? First of all, they're very data inefficient. Thus, they require simulators. For instance, it is not feasible to crash a car many million times before it learns a decent driving behavior. Additionally, reinforcement learning algorithms are very brittle with respect to the data distribution they experience during training. If this distribution shifts during the deployment, it usually causes severe performance issues. And in this work, we want to assess the capability of these model-based RL algorithms when they're trained in simulation and how they behave when they are deployed to real-world robots, like cars, for instance, and how well they compare against the state-of-the-art model-free algorithms. Why model-free? Because at this time, model-free algorithms usually outperform model-based RL algorithms in the limit. Our work is based on the algorithm presented in Dream to Control by Hafner et al. At ICML 2020. This algorithm is a model-based reinforcement learning algorithm, which basically has 3 stages. In the first stage, it rolls out the policy in the environment to collect data. In the second step, it uses this data to learn a dynamics model. It does so by using observations and using neural networks, for instance. It compresses these observations in an abstract and latent state representation. This representation is then used to train this hidden dynamics model. And it is trained by basically trying to reconstruct the observations from this compact representation, hoping that it learns to focus on important parts of the state. In the next step, it uses this learned model to train a policy in its basically imagination. That's why it's called Dream to Control. It uses the model to imagine trajectories solely based on its model without having to rely on possibly noisy observations. And this model is then basically a hidden MDP or Markov decision process, which is used to train a policy that issues actions. Our algorithmic contributions are threefold. We are the first to provide an end-to-end training pipeline for this algorithm, this Dream to Control algorithm for robotic tasks. The original work just focuses on games. Secondly, we introduced a policy regularization for smoother control policies because world model algorithms tend to have high frequency, low-level controllers. And third, we provide 2 new reconstruction models to reconstruct these observations. The lighter reconstruction model is basically analogous to the one in the original work, and the occupancy reconstruction model was the more performant one, predicts the patch, local patch of the agent or of the map of the agent in some vicinity, for example, 5 meters as it is depicted here. The problem setting we are located in is autonomous racing. And we want to train a policy in simulation, here depicted on the left. and transfer it to the real car depicted on the right. The problem consists of several parts. The observations we have are 2D LiDAR scans, as it is here visualized. The actions the agent can take are the motor force and the steering angle of the car to move it as fast as possible. We trained our agents on various tracks, also depicted here, with varying difficulty. And we designed a reward function that is based on basically the progress the car can make on the track. So the progress is just to measure how far it has gone from the starting line, and is measured between 0 and 1, and a penalty in case it crashes against the wall, for instance. We did several experiments. The first experiments were in simulation. Here we just wanted to see if our algorithm can outperform state-of-the-art Model 3 algorithms with this training budget. So we basically took the best performance of the Model 3 agents and compared it to the average here in solid lines to the 2 Dreamer agents. And we saw that it basically outperforms them. In every task in Columbia, they converge to the same value because it's a very simple track. The performance measure here is the maximum progress, which is the metric which I introduced before. So it is the progress reached within a fixed time window. In the second experiment, we tried to measure the cross-track generalization. That means how robust are these policies when they're trained on a fixed track and then deployed to different tracks. And here also the model-based RL algorithms tend to be far more robust against this, this distribution shift, basically. In additional experiments, we deployed the policy that we trained in simulation, the Dreamer policy, on the real car, and set up 3 experiments on our real-world track in Treitelstrasse, in the lecture hall. The first experiment was just driving in the default direction. Then we reversed the car to basically generate a new map. And finally, we also placed some obstacles that it did not see during the training. Here we can see some footage of the lecture hall and the car and the measurements. And I hope that the video works. I did not have great experiences with videos over Zoom, but let's try. We also made some videos. Can you see it properly? Yeah, here you can see the car driving in forward direction. We also made some videos where we reversed the direction. So here you can see it. It is accelerated because it's a video for a conference. It also worked. It generalized to the different directions. And ultimately, it also learned to avoid obstacles, even though it never experienced it during the training. Yeah. I hope you could see the videos. To conclude, given this training budget, it was much better than state-of-the-art Model 3 algorithms in these robotic tasks. We also observed that the observation model or reconstruction model heavily affects the performance and generalization. For instance, the reconstruction model that we named Occupy generated more performant policies, but did not generalize as well. And we also proved that it's possible to robustly transfer this policy learned in simulation to the real car without having to apply extra techniques for robustification like domain randomization. In future work, we want to assess the multi-agent capabilities of such world models and how to exploit continuous time models for this kind of task. Thank you for your attention.
Yeah, thank you. So,
could you see my videos?
Yes, everything
Okay.
Worked well. So, questions from the jury.
Yeah, so if I may,
Please
I
go
would
ahead.
start with my question. Yeah, thanks for the nice and clear presentation. I wonder, you presented the training like there is either no training or there is training, like it is a binary decision, but it seems that you can put different efforts into the training, right? Into this model generation. Can you comment on that? For one, did you try different efforts for training the model?
Yeah.
And is there any impact on that?
You mean the training budget, so to say?
Yeah, the budget for the model generation.
I mean, model and policy are learned conjunctively. That means it alternates between those two. We trained our model-based agents for 2 million time steps and the model-free algorithms with 8 million time steps. So we account that they need more data by giving them much more training time to learn policy. But still, these model-based algorithms outperformed them.
And this training time includes the model generation?
Yeah, exactly. Okay. It alternates. These are hyperparameters. It alternates between these 3 steps. So it rolls out a policy, updates the model, trains a policy. Using the new policy, it collects more data and so on.
Okay, I see. Thank you.
Thank you, Andreas. Renata was the next.
Hello. Thank you very much, first of all, for the nice talk and congratulations on the nice work. I had 2 questions, out of which Andreas already stole one of mine. So then I would have a more general question, which would be, what do you consider to be the biggest achievement in your?
I think the biggest achievement was to find out that we can learn a policy that was trained solely in simulation, not even high fidelity simulation. It was a custom simulator built by us. And when we tried it on the real car, it worked, which means it was a relatively robust policy. And yeah, this was, I think, the greatest achievement. I mean, there are some works addressing especially this distribution shift by randomizing the simulation, for instance. And we were able to do this without these extra techniques.
Okay, thank you very much.
Okay, yeah, Ihua.
Yeah, hello, can you hear me?
Yes,
yeah.
Hi.
Oh, great. So I have a very high level question regarding your approach. In general, so car racing is not very like daily life. I would like to know, or do you think that your approach can be, for instance, applied to other more human relevant applications, such as car driving, like using real human? Do you think that it is possible, or why not?
I think that it's not, or not, at least not in the near future, to end train such an algorithm to do regular driving in traffic, because it's just far too unstable. As I mentioned, these problems of brittleness to distribution shift still apply, but we can reduce them using this model-based algorithm, for instance. But still, it's not. There's no provable guarantee that you have and would be required, for instance, for car driving. For example, Tesla now has serious issues with their new machine learning-based autopilot, which regularly crashes still, even though they have huge models and extreme amounts of training data. So I think it's possible to help in some situations, but right now it's not possible to basically do this using just reinforcement learning, in my opinion.
I see. Thank you.
Okay, so thank you very much. Time is more or less over. So I try to play around here with my screen share in order to introduce the next speaker. So sorry for this. But somehow, I hope now it's okay. So our next candidate is Tobias Geibinger. His thesis is entitled Investigating Constraint Programming and Hybrid Answer Set Solving for Industrial Test Laboratory Scheduling. Yes, and he's supervised by Nusret Muslio, and I stop share. And I see Tobias is ready.
Yes, did it work? Can you see my screen?
Yes, you are doing this in a much more efficient way than I do. So yeah, I will set the time to 0, and now it's your turn.
Okay, thank you for the very kind introduction. Since Stefan already mentioned the title, I will not repeat it again, it's rather long. But I would immediately like to show you this little device, which I guess most of you will not recognize, even though you have used it before, at least implicitly, simply because it is the control unit contained in a car, which is used to control the engine. And this is an electronic component, meaning that it's subject to potential interference by things like cell phones, radio waves, or any other kind of electromagnetism. So ideally, you want your control unit to be shielded against such things, simply because you do not want your car to stop whenever your phone rings. Now, this takes us to the setting of this work, which is also the setting of the industrial partner of the project this work resulted from, which is a test laboratory. In this test laboratory, among other things, such electronic parts are checked for potential interferences, and those tests have to be performed according to several norms, simply to ensure that those parts, when they get put into production cars, they are safe. Now, what we focus on here is the scheduling of those tests, which is rather complicated because there are a lot of tests being done simultaneously, and also all of the employees and also the equipment is certified for specific norms or tests. So it's not like everything can be done by anyone and everything. So you really have to make proper assignments to your resources here. I already mentioned that this is important for cars, but such test laboratories also exist for aerospace engineering, so for planes, but also for medical devices like X-ray machines, or even simpler things like common household appliances. And in general, such a scheduling problem appears in any kind of test laboratory. Now, how does this look like? Well, our goal is to schedule the tests, which we also denote as projects. Each project contains several jobs, which have to be assigned start times, and also the required resources in a way that there are no conflicts, and also all of the qualifications are upheld. Now, we also are looking for good schedules or optimal schedules, because we prefer schedules that have low project durations, the projects keep the due dates, and also we want to minimize the number of employees involved in each project, and also there are certain preferences of which employee gets assigned where that we wish to uphold. Now, what the situation before we started this work was something as follows. So there was a human planner who was in charge of creating schedules, and this person was an expert, and the creation of those schedules was rather time intensive, and the result was often not an optimal schedule. The schedule was often incomplete, and in some cases it was plain simply inconsistent in some form. So there were some issues that had to be worked out later than in practice. And even though in our setting there was only one human planner, we know for a fact that in other test laboratories there are actually whole teams of people involved in doing this scheduling. So the question that naturally arises is, can we automatize this somehow? Because obviously you would like it if a computer could do this job, or at least help with it. Now, the problem here is that this scheduling problem is a rather hard problem. So the number of possible assignments is exponential, which in practice, in a practical example, results in a number of assignments that's roughly 2 to the power of 2 to the power of 18, which is a really, really large number, more than the number of stars in the universe, for example. So a naive algorithm here is not going to get you anywhere. So what did we do then? Well, first we looked at how the human plan actually solves this problem, which is by utilizing domain knowledge, consisting of things like the constraints of the problem, but also the preferences, which solutions are better, and of course of the qualifications and the other things needed to actually make a schedule. We took this domain knowledge and created a mathematical problem formulation, which represents the problem in a formal way. Then, using this formulation, we encoded it with different paradigms, because those encodings allow us to use specialized software, which takes the problem, the encoded problem, and produces solutions, and the solutions here then are just schedules. So using those different encodings, we investigated different options. We actually managed to create a solution approach that produces relatively good schedules fast. So this is one of the main contributions here, that we provide and investigate different encodings for the scheduling problem. Now, finding the right encoding is not always so easy. So there are a lot of things you need to consider. Like you always, of course, need to encode the right problem, but there are also differences in the symmetries of solutions or at the search space. So the encodings more often than not differ vastly in performance, and this is an iterative process, so you tune a lot. And also sometimes you really have to check this empirically, so you need to do benchmarks and see which encoding option actually works best. Now there's another part of the domain knowledge that I have not talked about yet, which is problem-solving heuristics. So the human planner naturally has some way of producing a schedule. So it doesn't go at it at random, but it rather decomposes the problem a little bit and does it iteratively. And so the question was, can we use this, this approach also for our solution method? And the answer is yes, by using something called very large neighborhood search. So the idea is here as follows. So in the first step, we compute some lower bounds, which just means that we optimize each project in isolation, and for each project we get a value. And this value is then the minimum penalty induced by the project in any solution. And if we sum up over all of the lower bounds, we get the lower bound for the whole instance. As a next step, we obtain an initial solution using some of our encodings. And in this solution, we then fix everything but one project, where we make sure that this project that is not fixed actually has some potential for improvement. So here we use our lower bounds to see, okay, which project can actually still improve. And also we have a short-term memory that ensures that we do not pick the same project multiple times. Now, after we have done this selection, we optimize the schedule and we get a better solution. So since we have a better solution, we check whether or not we have reached the lower bound. If so, we have found an optimal solution and we can stop. If not, we possibly increase the selection. So we pick more than one project if we have already tried all of them, all of the single ones. And we do this again until we reach the timeout or until we reach the lower bound at some point. Now, for our method, we conducted several experiments using a benchmark of 31 instances, including real-life data. Here you can see the results shown as the relative quality of the solutions found. On the very left, you can also see the previous state of the art, which is a meta-heuristic solution approach for the problem. And here in the middle, you see the results of some specialized solvers for encodings, including, for example, the commercially used IBM CP optimizer. And on the right, you see the results for very large neighborhood search approaches. Each of them uses one of those specialized solvers internally. And can easily be seen that the results of the very large neighborhood search approaches are the best. And one of the approaches, the one where we use a constraint answer set programming solver internally, clearly achieves the best results in almost all of the cases. So what does this mean for our benchmark set? Well, we managed to optimally solve 21 instances, and out of the remaining 10, we know that 9 of them are within 5% of the optimal solution. So as a result of this thesis, what did we achieve? Well, we did not replace the human planner, but we gave them a tool they use daily to produce high quality solutions, high quality schedules. Now, to conclude, I will go over again over the contributions and the publications that resulted from this thesis. So we investigated a constraint programming encoding approach, where we reviewed different encoding options, but also provided novel redundant constraints and search enhancements. We investigated constraint answer set programming, which is actually a first in the realm of project scheduling. And again, we evaluated different options. And lastly, we provided a very large neighborhood search framework with adaptive project-based neighborhoods and also this novel lower bound generation. And as already said, this very large neighborhood search approach is the state of the art for this problem, and it's also what is used in those daily operations. As for the publications, we have a conference paper at AAAI last year. There was another conference paper at CPIOR, and this publication was then extended to a journal version, which was submitted to the Journal of Scheduling. And this concludes my talk, and I'm happy to take any questions.
Okay, thank you very much, Tobias. Questions? Andreas was the first again.
I don't want to monopolize, so if others want to start, I'm fine. But anyway, so yeah, thanks again for this nice presentation. I was happy that your presentation was more in the like an introduction, but this kind of triggered my follow-up question now. So as far as I understand, there are many scheduling problems and many scheduling algorithms. So what was specific for this problem and for the solution that this combination of problem and solution turned out so optimal in your case?
Well, the problem is basically a project scheduling problem, so they are all somewhat related, but this is really an extension. So it has some features that are not included in any of the existing ones. So as an example, we track individual resources because we have those qualifications. And this is something that does not that often appear in the literature. So usually you have that the resources are all the same, but here we really have some employee is qualified for this, this, and that. So he can he cannot be assigned for something he's not qualified for. And this is also why we had to develop those encodings, maybe not from scratch, but it's still somewhat novel of the things we had to encode.
Mm-hmm. Okay, thank you.
Okay, thanks. So now I will give the word to Thomas Gärtner, since he's one of the jury members we have not seen yet. Hi, Thomas.
Video, I'm not cooperating. Yes, now. Okay, thanks for the nice talk. So I was wondering, you said when the algorithm will stop when you attain the lower bound, but you're probably not guaranteed to attain the lower bound. So you have to stop somewhere else. Do you search the whole search space, or when do you stop? And do you have a guarantee after what time you'll get how close to the optimal solution?
Well, you are precisely right that we cannot hit the lower bound every time. I mean, for some instances, you can also exhaustively search, basically, if they are small, because you increase the number of projects, and at a certain point, you just have the whole problem again, and you will try to solve the whole problem. And if you do so, you have found the optimum. Otherwise, we usually pick a timer of 2 hours for those experiments you've seen, because this is simply how the timer that was chosen, also in collaboration with the industrial partners. As for guarantees, we cannot really give them, no. So you really just have the lower bound, and a value that's close to the optimum, but it might be lower, but you cannot really tell when you actually will find a solution that is that good. But
okay, thank you very much. Oh.
Yeah.
Okay. Thank you, Thomas. So before asking the final question, let me just mention that in the meantime, our rector has joined us, and we will make a mini break between this talk and the next talk. So just for the preparation of the third presenter, and then we will have the welcome address, so to say, as a short highlight in the break, as a break after this Q&A session. So here we have time for one more question. So I give the word to Ihua.
Okay, yeah, thanks for the nice talk. I have a very specific question regarding your contributions. So in your contributions, you say that you provide novel redundant constraints for your constraint programming. And then you say that it improves on the performance. So how can you maybe explain a bit, how do you compare this improvement? So how do you know how well it improves?
Well, in this case, empirically. So you really take the benchmarks and you try it with the redundant constraints and without, and you check which performs better. So, because I mean, logically, the models are obviously equivalent, but the way constraint propagation is implemented, it helps to have redundant constraints. So this really improves that you find solutions, but you cannot really check this independently of any example.
So there's no measurement on that. So like some measure that you provide.
Well, only the runtime. So it's an experiment that is performed.
Okay, thank you.
Okay, so I think, yeah, we do not have more time for further questions. So thanks again, Tobias, for your presentation. And I will try to now quickly move to this slide, which gives me the opportunity to welcome our rector, Sabine Seiler. It's always a great honor when you visit our Epilog, and we are, of course, very happy if you can say a few words. Thank you very much.
Well, thank you very much. I am not only too late, I have also technical problems so that you don't see me, but I think you can hear me, I think. Okay, so it's not the welcome address now, it's a middle address or so, but I think you can see that I'm very interested in the Epilog itself, and especially in the Epilog at the end of the winter semester, because we will see the presentation of 4 awards, not only the best diploma thesis and the best poster, but also the prestigious Bachelor of Honors certificates and the Siemens Award for Excellence. Unfortunately, we are not into the sky today as planned, but in virtual space. But who, if not the Faculty of Computer Science, is in a position to make a virtual award ceremony just as much as a festive event as a physical one? The last 2 years have demanded a lot from us, but I think we have also learned a lot, and we must use these experiences to rethink the university itself. Universities are communities of learners, academics, and professional staff with open boundaries, including alumni and a wide range of partners and citizens. They will continue to characterize to being cooperative and networked institutions locally, nationally, and internationally. On the one hand, universities are places of respite and refuge to test new ideas, for lateral thinking, and for creating new knowledge that still lies outside of mainstream awareness. On the other hand, knowledge production can benefit from a dialogue with society, actively involving citizens and non-academic partners such as business, non-governmental organizations, public authorities, and others that share objectives with the university. Both areas will remain fundamental for the university's service to society. The nature and structure of universities will be hybrid. They will be open as physical and virtual spaces and will work to cultivate both of these when engaging with society. In the future, this will entail that physical and digital learning and research environments must be designed in a holistic way to accommodate the different needs of a diverse university community and allow for flexible and blended approaches. The physical campus will continue to be crucial as a place for social interaction and dialogue. A place that will host encounters that challenge and inspire, but will also offer quiet spaces for focused learning and research. The virtual campus will make the university ubiquitous. It will be developed to improve access for all to participate in research and learning, enhance cooperation, and explore new, innovative ways of pursuing university missions. Events such Epilog, where achievements are presented as part of a competition, but also cooperation with industry partners are an important element in profiling the university as that bridge builder. And I'm sure this applies in particular to technical universities. My thanks go to everyone who contributed to the success of today's event, and especially to Siemens Austria for making the Siemens Award for Excellence available. I'm keeping my fingers crossed for the 4 finalists. I think 2 are waiting for their presentation. And I'm, of course, with all of you. It's a great privilege to work and study at a university with so many talented people. Thank you very much, and so sorry for the delay again.
Hey, thank you very much, Sabine Seidler, for the kind words. And we are, of course, all are looking forward very much to meet each other in person for the next Epilog. And yeah, thank you again.
I will do my best to be in time next time.
Okay, no, but I mean, for the first time we have the how to say, the effect that we have a welcome address between the presentations. So yes, we might make it a tradition, so that surprisingly someone pops in and the students have to adapt. No, but thanks again, and I should now be able to share my screen now so that Victoria doesn't need to wait any longer. So, and it's just for introducing our next speaker, Victoria Korchemner. Her thesis is entitled "The Complexity of Bayesian Network Learning: Revisiting the Superstructure," and it was supervised by Robert Gagnon. So let me just set the clock. In the meantime, don't hurry. You still have time to share the screen.
Hello, everyone.
Hi. So let's try to have it full screen, maybe the slides.
Yes, of course. Yes.
So take your time. Time is not running yet. So.
Okay. So as you already announced it, the name of my thesis was Complexity of Bayesian Network Learning.
Sorry, Victoria, just sorry for interrupting. We do not see the first slide, and neither do we see the slide in full screen mode. At least for me. I mean,
okay, I'll try again.
Now I see the title. If the title has cats on the slide, then it's good.
Can you see it now?
Now it's perfect. Okay, so now I will start the timer. So the stage is yours.
Thank you. So name of my thesis is Complexity of Bayesian Network Learning Revisiting the Superstructure. Bayesian networks were invented by Jude Apparel as mathematical formalism for defining complex probability models. It is very important now and very widely used in practice. For example, in medicine, in image processing, or system biology. And that's why Judea Parallel even was awarded by Turing Award for this invention. Bayesian networks are directed acyclic graphs where vertices correspond to random variables, and arc from one variable to another depends that second variable depends on the first one. For example, here you can see a network of behavior of cat, and you can see that one variable can depend on multiple variables, such as whether cat hides depends on rain, whether place is safe, and whether dog is noticed. And there also can be variable which doesn't depend on another ones, independent variables. The problem of constructing Bayesian network of optimal structure can be formalized as follows. In input, we are given set V of nodes that correspond to random variables. For every node, there is a local scoring function, and there is a target score L, which we want to achieve. The question is whether there exists a directed acyclic graph on set of vertices V, such that sum of local scores is at least target score L, where local scores are evaluated in sets of in-neighbors of vertices in the graph, or we also will call them parent sets. For example, here we are given 3 vertices, A, B, and C, and want to achieve a total score of 5, and local scores are provided below. Here is one of possible solutions. Firstly, we add arcs from A and C to B. Now B has local score of 3. Then we add one more arc from A to C, and now C has local score of 3 as well. And A has empty parent set, so its local score is 0. So total score now is 6, which is greater than 5, so this is a yes instance. However, the problem is in general NP hard, which motivates further research from parameterized complexity viewpoint. Hardness appears because we cannot just greedily choose best parent set for every vertex, because we also should make track of acyclicity. There should be no cycles in resulting network. Fixed parameter tractability allows us to make a problem which is not tractable from standard complexity viewpoint. As you can see in picture, for example, it has exponential running time, but we can distinguish some part of input, K, which is called parameter, so that the blow up and complexity is only localized to this small part of input. Then running time of problem becomes some function of parameter times only polynomial of size of input. So our task is to choose a suitable parameterization for Bayesian network learning so that it becomes fixed parameter tractable. For this, let us define superstructure graph. We start from vertex set V from input and then add edge between any 2 vertices such that for one vertex there exists a parent set yielding non-zero score containing another vertex. And the resulting graph we call the superstructure graph. For instance, in last example, A has parent set B and C yielding non-zero score, so we add edges from A to B and from A to C. Also, B has a parent set AC yielding a non-zero score, so we should add edges from B to A and to C. Now it's just a click on 3 vertices, but it's not always the case. For example, if we would have one more vertex D, which has the only parent set with non-zero score BC, then we would add edges from D to B and C. We will parameterize by structural properties of the superstructure graph. It was already studied before. For example, Ordiniak and Sider showed that BNSL is not FPT if parameterized by the vertex cover number of the superstructure. Vertex cover is a set. Vertex cover set is a set of vertices such that every edge in graph has at least one endpoint in this set. For example, in pictures below you can see that red vertices form a vertex cover, and this is a very restrictive parameter. So hardness by vertex cover number implies hardness by less restrictive parameters such as tree depth, path width, and tree width. However, there are still edge-based parameters such as tree cut width and feedback edge number, and for them the problem wasn't explored before. So we want to explore it in our thesis. Actually, we explored already. So we showed that the W1 hardness also holds for tree cut width, but for feedback edge number, we provide a data reduction procedure, which automatically implies that the problem is FPT. However, there is quite a big gap because feedback edge number is very restrictive parameter, and we want to introduce less restrictive parameter, but still keep tractability. We introduce local feedback edge number, and it turns out that we can lift fixed parameter tractability to this number. However, data reduction already doesn't exist under standard complexity theoretical assumptions. Feedback edge, so let's take a closer look on these results. A data reduction, which is sometimes also called a kernelization, is a procedure which takes input, which takes instance of problem, and then runs in polynomial time and creates equivalent instance, but now the size of this instance only depends on a parameter k. So it's similar to extracting a core from a fruit or nut. In our case, we consider as a parameter feedback edge number of a graph, its minimum size of edge set such that deletion of these edges results in forest, and we provide a data reduction for this parameter. The hardest part is actually to get rid of long induced passes in the superstructure graph. And for this, we create a gadget where every long induced pass is replaced by only 3 vertices, so that every possible configuration which could appear in this original path is captured by new 3 vertices, so that every sum which was originally achieved by these m vertices now is achieved by 3 vertices. However, as I told, it's quite a restrictive parameter, and we can take a look at this graph. This graph has quite a simple structure, but already feedback edge number of this graph is 8. You can see that black is one of possible spanning trees, but there are still 8 edges outside of spanning tree. So feedback edge number of this graph is 8. But if we take a closer look, we can see that every vertex, for example, blue one, only locally interacts with only 2 cycles containing 1 red edge. And we want to be able in this case to say that local feedback edge number of this vertex is 2. And the same holds for every vertex. So local feedback edge number of graph is 2. And this shows that BNSL is fixed parameter tractable when parameterized by the local feedback edge number of the superstructure. To conclude, our results complete the picture of parameterized complexity of Bayesian network learning with respect to fundamental parameters of the superstructure. We also provide FPT algorithm for a special variant of BNSL in so-called additive representation. There are numerous possible directions for the further research. For example, newly introduced parameter can be used in another graph theoretical problems. We already started to do this in our next article. And there are also can be more efficient algorithms for computing local feedback edge number. And also, to mention publications, extended results of this thesis were presented at the oral session of NeoRIPS 2021. So thank you for your attention. That's it.
Okay, thank you very much, Victoria. Questions from the jury members? So Thomas was the first this time.
So thank you for your very nice talk and congratulations to the newspaper. What I didn't get at the beginning, you mentioned you have a scoring function, and I was wondering where that scoring function comes from. And the second question would be, have you considered an extension to undirected graphical models such as Markov networks?
About scoring functions, they are provided for us as part of input, because there are two parts of this problem in general. One part is constructing scoring functions from observation data, but in our setting, we already have them as part of input, and we assume that scoring functions are decomposable, because in general, they can depend on graph in whole, but we consider when they are decomposable over vertices, and for every vertex depend only on its parent set.
But so in terms of the random variables that correspond to the nodes in the graph, what is the scoring function?
The scoring functions are designed so that when a set of observation is given, we want to attach to every vertex a score, so that the score is maximized when, if we construct a network where the vertex, I just want to move to network. So if we construct some network, we want so that scores were maximized when dependencies represented by arcs correspond closely to real life. For example, if the experiment shows that usually when place is unsafe, dog is noticed and tomcat is noticed, then cat runs away, then we will get the highest score for this vertex run away exactly when she has these three vertices as parents in graph.
I see. Okay, thanks. And the other question was with the undirected graphical models. Did you consider that at all or not?
No, about indirect that we didn't consider.
Okay, fair enough. Thanks.
Okay, thank you, Thomas. I have Renata on the list now.
Hello, thank you very much for the nice talk. So I have two small questions. So the first one is, if you can comment.
Can you speak a bit louder, Renata?
Yes.
It's hard to hear. Now it's better.
Is it better now?
Yeah,
okay, yeah. I have to be closer to the mic, sorry. So my first question was if you can comment a little bit more on the sensitivity of your approach to the elephant parameter. And the second question is if you have a feeling of what other scoring functions you could also use in a suitable manner.
About scoring functions, we didn't consider any specific kinds of them, but in our last section, we considered a bit about scoring functions which are additive. So when they can be represented as sum of scores per one arc, maybe this can be used in some approximation algorithms. And for this, we also get another result, which I didn't mention here just because of lack of time, that the problem is fixed parameter tractable in additive representation, parameterized by trees of the superstructure graph. And about parameter, we showed that, can you please say again what was about sensibility?
Yeah, it's if your approach is like if you're changing this parameter, if it's somehow like affecting too much or too little your outcomes. That's what I meant.
Okay, there is exponential dependence on this parameter. I mean, it's something 2 to the power, some linear, some quadratic or cubic function of the parameter, and then times polynomial of size of input.
Okay, thank you so much.
Okay, thank you. We would have time for a very short question with a very short answer. Okay, people have only prepared long questions, so yeah, so I think then otherwise the 15 minutes are over. Thank you very much again, Victoria, for
Thank you.
The presentation. And
I'm on share now.
oh, I will overshare, so to say, if I manage to do this correctly. Yes, and this brings us to the final presentation of the first part, of course. So we will now see Sebastian Matzer presenting his thesis entitled Homomorphic Encrypted Volume Rendering, which has been supervised by Ivan Viola. And I need to stop share. Here I am. And I already see Sebastian being here. That's good.
Yeah.
Okay, so we see only, I think, only the, okay, now it's fine. And I will start the timer now.
Thank you. My name is Sebastian Matzer, and I will present what I have done for my thesis on homomorphic encrypted volume rendering. I want to start with a short explanation of volume datasets and how to render them. Volume datasets can be acquired from CT scans or magnetic resonance imaging. You probably know these techniques from medicine. A volume dataset can be seen as a three-dimensional space-filling grid. A point in such a grid is called voxel and typically contains a scalar value, and this value usually describes the density at a certain point in space. Probably everyone knows visualizations of CT or MRI scans that shows only a single slice of a volume dataset. Showing slices that cut through a volume is a very basic visualization technique for volume datasets. 3D visualizations of volume datasets can be more expressive and easier to understand, but require a lot more effort to create them. Since 3D volume rendering is a memory and computational intensive task, and therefore powerful workstations are required, and these are expensive and not really mobile. Performing the required computation on servers would be an efficient approach, since many users could use the same server infrastructure. And the rendered images could be streamed from the servers to cheaper mobile devices that only need to display the images. The problem with this idea is the privacy of the volume datasets and the rendered images. You need to trust every person who has access to the servers. Persons like the owner of the server or the maintenance personnel that has access to the servers. Even if you trust all of them, there could be some security breach that allows third parties to steal your data. Therefore, it is currently not possible to responsibly outsource volume rendering. At the time when only analog X-ray images were available, it was easy for patients to keep their sensitive images secret, since only one copy exists. But in our digital world, where perfect digital copies can be made easily, the privacy of your most sensitive data about your body and your diseases are in danger. However, the target of my research was to find a way to change that. The approach should be secure by design. The security should not depend on hiding implementation details or making the algorithms artificially complex or some other obscure techniques which will probably be cracked sooner than later. Our approach should be provable cryptographically secure. Only the owner of the data who has the private key should be able to make any use of the data. Furthermore, we want to perform all aspects of the volume rendering on the server side. Only the final image should be sent to the client. The support of sync clients prohibits techniques that performs part of the rendering on the client, since sync clients don't have the required hardware resources. One key foundation for the approach I introduced is the idea of homomorphic encryption. Homomorphic encryption schemes makes it possible to perform operations on encrypted values. And these operations translates to operations on the plain, non-encrypted form of the values. Let me demonstrate that by an example. I used the Bachelor crypto system and the equation 5 + 3 = 8 for my example. With the help of the shown 16-bit public key, we can encrypt the values 5 and 3. The encryption is asymmetric and probabilistic. And the security factor is comparable to those of the well-known RSA crypto system, which secures millions of connections for various websites every day. The encrypted values are 32-bit long. If we now multiply the encrypted representations of 5 and 3, the result is a 64-bit long number. As a next step, we can reduce the size of the product from a 64-bit to a 32-bit long number without losing any important information. This can be achieved directly in the encrypted domain by calculating the modulus by the squared n of the public key. For the decryption, the private key is required. It contains the 2 prime factors of the modulus n. The prime numbers are stated as p and q. With the correct private key, we can decrypt the last result and get back 8, which is the correct result of the initial equation. This example demonstrates that it is possible to solve an equation without even knowing the operands. So a server can calculate the sum of 2 numbers without ever knowing these 2 numbers or the sum. This is like building something that you can see from a material that you don't know. In the previous example, I used a 16-bit public key. This is way too short to be secure. On this slide, you can see an example of a key with a 2000-bit long modulus, which is secure. Below, you can see the number 3 encrypted with this 2000-bit long public key. For us, the big question was, is it possible to render an encrypted image from an encrypted volume dataset in a homomorphic encrypted domain? The problem with homomorphic cryptosystems is that they are slow and the computations that can be made are very limited. There are already fully homomorphic cryptosystems which theoretically can compute every possible operation in the encrypted domain. However, these schemes require too much storage and are too slow for practical implementations. Therefore, the challenge was to design a 3D volume rendering with the limited possibilities of a non-fully homomorphic cryptosystem. I use Baylor's cryptosystem, which I already mentioned. It's efficient enough for an implementation that is able to render a real-world data set on a common computer hardware. However, Baylor only supports a homomorphic add that can calculate the sum of 2 encrypted values. And it supports the multiplication of an encrypted and a plain text value, but it does not support the multiplication of 2 encrypted values. This limitation makes it necessary to develop unconventional ideas in order to achieve a 3D volume rendering. The privacy-preserving volume rendering I introduced in my thesis includes 3 components: the acquisition device, the server, and the client. The first part is the encryption. It must be done before the data is uploaded to the server, and it would make sense to do it directly after the data acquisition. During the volume encryption, every single voxel value is encrypted on its own. Metadata like the size of the volume are not encrypted. After the encryption, the dataset is uploaded to the server. Now a client can send a render request for this volume dataset to the server. The request includes camera parameters like the camera position, image width, and so on. The server uses this camera data to perform a raycasting directly on the encrypted data. After the rendering is completed, the client downloads the rendering result and decrypts it with the secure key or private key. In my thesis, I introduced new approaches for homomorphic raycasting with X-ray compositing. This also includes an approach that makes it possible to approximate the final division that is required for array normalization. In order to improve the visual quality of the rendered images, I developed a trilinear interpolation of the voxel values. I also introduced an approach for a simplified transfer function that makes it possible to map encrypted density values with random noise in it to encrypted RGB values. This can be used to highlight interesting values. I did not only work out the theoretical concepts, but I also did the first implementation in Java, which demonstrates that my concepts are really feasible. Furthermore, I did a GPU implementation for my encrypted volume rendering approach. And best to my knowledge, this GPU implementation also includes the first library for the Vulkan Graphics API that can handle calculations with integers that are thousands of bits long. I made all this C++ and OpenGL shading language code freely available on GitHub. My approach makes it possible to render images from volume datasets like this. And if you know the correct private key, and only then, you can decrypt them and they will look like this. The first one shows a water globe wrapped by 2 boxes. The other 2 images are rendered from the exact same encrypted dataset, but with 2 different transfer functions. The underlying dataset is a CT and PET scan from a patient with lung cancer. I see my work as the beginning of privacy-preserving volume rendering. And it seems that there is an interest for that technology, since I got the opportunity to present our approach at the greatest visualization conference, the IEEE WIS conference. I hope that further research will lead to less overhead and better efficiency. Bringing some of the more sophisticated rendering approaches into a homomorphic encrypted domain could also be another interesting research topic. That was my presentation on homomorphic encrypted volume rendering. Thank you for listening.
Okay, thank you very much, Sebastian. So this time, Margrit, good to have you here. Hi.
Yeah, thank you very much for your nice presentation. So my question is, well, at the end, you mentioned the computing efficiency and storage. Can you give us an idea about the problem size on which you tested your method? And my second question would be, how would that, what about upscaling to even larger amounts of data? Can you make a comment on that?
Yeah, that's a good question. So the security doesn't come for free. So a longer modulus means that it's harder to break the encryption. But it also means that the required storage size increases and that the calculations are harder to solve because of the longer numbers. The GPU implementation I tested with 256, 256, and 256 voxels with a volume that has 256 voxels in every dimension. That's maybe a bit low for what CDs and so on can do to date. But with this and really fast servers and a modulus size that is probably enough for most people to secure their data, it's currently hard on the edge to be interactive.
Okay, thank you.
You're welcome.
Thank you. And so next on the list is Renata.
Hello, thank you very much for the nice talk. So I would have just one question about what would you be required to do in order to be able to integrate, let's say, more advanced volume rendering capabilities, like, for example, multidimensional transfer functions, or maybe to be able to render multimodal volumes?
The thing is, it depends what you can do with the homomorphic encryption scheme you choose, and how you design your encoding. And I think it's possible to do more than we have shown at the moment. That was the first proof of concept that it is even possible to do this really. And I think further research will be needed to find out what can be done with other homomorphic encryption schemes or with smarter encodings.
Okay, thank you so much.
You're welcome. Thank you.
Okay, we have time for one more question. Yuva?
Okay, thank you. Thanks for your talk. So I have a very specific question. So as far as I understood, your approach is an asymmetric homomorphic encryption approach. I'm just wondering whether you have already looked into the symmetric key homomorphic encryption approach. My question is based on your efficiency statement. So if you use symmetric one, maybe you can render the data in more efficient way. So I'm just wondering whether you have looked into that.
Yeah. Most of the symmetric things I saw are not really a good choice for volume datasets, in my opinion. I mean, maybe there are schemes that can solve that problem, but I'm not aware of any of that. Since the thing is in the dataset, there are probably millions of voxels with the same value, with the same density value. So, for example, all the bones has nearly the same value. And with symmetric encryptions, the problem is that you can find this structure. You don't know what the actual value is, but you can probably find out that there is a structure with a certain density in that volume.
Thank you.
Okay, thank you very much, Sebastian. Maybe you can stop the sharing now, and let me at this point also take the opportunity to thank all the four speakers for their, as far as my opinion counts, for the excellent presentations we have heard. It's very exciting, so thanks again. And I guess you all agree that our jury now requires some time for consolation to determine who will be the winner of the Distinguished Young Alumn Award in this winter semester. So this brings me to announce the next time, because of course in this break where we will have where the jury needs to discuss and deliberate on the winner, we have prepared some exciting program, of course. And it is my great pleasure now to introduce Daniela Borgmann from Siemens Austria. I will, if I manage to do what I want to do. Let's see. Just a few words about this, our guest. Oh, sorry for this. So now it should work. So Daniela Borgmann has studied bioinformatics at the University of Applied Sciences in Upper Austria, so that's Hagenberg, as you all know. After that, she has been a research associate at Helmholtz-Zentrum in Munich, and also then back in Hagenberg. And she joined Siemens in 2017. And I was told that she will say a few more words about her projects and work in Siemens during her talk. So therefore, without further ado, I would hand over to Daniela Borgmann. Welcome at our Epilog, and we are looking forward very much to your talk. Just for the audience, so this is now scheduled for around 30 minutes. We will have a short Q&A session in the last 5 minutes of this 30 minutes. So that's the rough plan. So now the floor is yours, Ms. Borgmann.
Okay. Thank you very much for the kind introduction. I hope that you can now see my screen, hear my audio, and see myself in the camera. Is that right?
Everything like is perfect. All three aspects.
Okay, then I will be not disqualified. That's good. Okay, so first of all, thank you for the nice introduction, and thank you for having this opportunity to speak here with to all of these people. And it was already really such exciting to hear about the things that you have done in your research. I feel a little bit back in time. As you heard already, I was also a little bit included into research a few years ago. But what am I going to talk about today? The title of my talk is Applying Energy Management and Predictive Maintenance Using Edge and Cloud Computing. So you can see there are a lot of big words in it, like edge and cloud stuff. I want to give you today a short overview about projects that we are doing currently at Siemens with a specific customer focus on edge and cloud computing. But before that, I would like to give you a short hint about my journey so far, and it was already a little bit included in the introduction. So I studied bioinformatics at the University of Applied Science Upper Austria, Hagenberg. So maybe some of you might know. I did there my bachelor and master degree. So honestly, the data science part that we have seen so far really affects my heart. I love it. So this is my background. I've been with the University of Applied Science then also afterwards, after my degree program. I was there as a research and teaching associate. I was a member of the bioinformatics research group there, according to my degree program. And I was also teaching there in the software engineering degree program, the beloved field of mathematics and the logical and formal fundamentals. After that, I decided to switch a little bit my focus. I went to Siemens and started there as a web developer in the field of IoT solutions. So it seems like a complete different field then. I agree. The thing was I wanted to have a little bit more of a customer focus in my career, and therefore, yeah, the switch was needed, and the switch was also a good choice. Currently, my position is, as you have heard, R&D project lead. So I'm trying to lead and administrate and guide projects that we are doing in the context of IoT and edge computing at our site in Linz. So some of you might have now some questions like, bioinformatics for real? Why would you work then on IoT projects? And isn't that a completely different field? And I agree with you, it sounds like complete different fields. If you take a look at these two images, on the left-hand side, you can see some genome analysis from the bioinformatics part. So I think bioinformatics now is all in the media with, unfortunately, the pandemic that we have. But you can see on the left-hand side some kind of sequencing analysis. So a lot of data. On the right-hand side, you can see an industry building where you can see a lot of machines there and all data coming in. And now I mentioned already a word which combines these two fields, data. Data is everything. And I think you know that also from your degree program and from all the analytics that you are doing. If you got enough data and if you got the ability to analyze this data correctly so that it maybe also benefits for somebody like your customers, you're doing a really great job. And that's what I wanted to introduce to you today. So I've divided my talk into 4 parts. The first one, I would like to give you a little bit of an introduction into cloud and edge computing. So what are the concepts? When are we using which technology? And what are we going to do maybe in the future? And the second part and the third part will be some real life scenarios. So I will present to you 2 real life applications that we are currently developing and that are already in use at the customer side. So the first one will be smart condition monitoring. It's a smart solution and it's a cloud solution. So here we are diving a little bit into the cloud technologies. And after that, I would like to give you a short glimpse on the energy efficiency labeling. That's an edge solution that we are currently building in Linz. And afterwards, we will just do a little bit of a wrap up and then we are already through it. And I hope you enjoy this talk. So let's start with the first thing with industrial IoT. So industrial IoT, the Internet of Things, is a really important thing that I think really grew over the last years. So I'm not sure how much you have learned in your degree programs about cloud and edge computing. So I'm sorry if I'm not telling you all the things that you already know, but maybe I can give some of you a little deep dive into what we are here targeting. So let's start at the bottom. We do have at some point at our customer side machines. We do have factories out there. If you think about, we heard about cars today, a car manufacturer, they have a lot of machines in the factory. This is called in our terms, the field level. There you got all your PLCs running, all your how to say, production is running, and you do have all your data available. And therefore, as your data is all available on the field level, on top of that, the edge computing technology was introduced. So edge computing means computing really near to the machines, and they're really also, how to say, locally spaced near the actual device where the data is generated. What does the edge computing have as on the advantage side? As I mentioned, you are really near at the data. So that means you got access to it. You got immediate access to it, and you got a lot of data available. Pros, of course, edge computing, if you want to access the data, you most probably need some device that need to be put in the factory. And of course, this device has some limitations. So for instance, there are a lot of edge technologies out there at the market, also of course, not Siemens branded. I can tell you now the Siemens solutions, those are little industrial PCs. They are that big approximately. And of course, they do have limited resources, like if you think about the memory or the CPU. So you cannot do all the computations that you would like to do with your data analysis part on edge. And therefore, and yeah, that's one reason why there's also the other part at the top of the edge computing, it's cloud computing. So cloud computing is most of the time used if you want to access your data also all around the world. So we all know cloud solutions. We all know social media like Facebook, like Instagram, you can access it worldwide. And that's also a thing that industry is really taking advantage of. If you think about, I would take the example, a car manufacturer, they do have factories at multiple places around the world. But I think there will be some people really interested into getting to know whether all factories around the world are really performing, are really running. And it wouldn't be a good approach to go in each factory and see if everything is working there as we want to have it. And therefore, if you put your data to the cloud, you can analyze it there. You can, of course, benefit from the resources that we do have in the cloud, like a cloud provider is providing us a lot of also capabilities to do the analysis, like Microsoft Azure or AWS. And of course, that's the big, big advantage. Disadvantage, of course, there's also one. You need to bring this data to the cloud. And therefore, I like this layer image, because as you can see, the distance from the field level to the cloud is really more than the distance to the industrial edge or edge computing layer here. And of course, I think we all know that from home office or homeschooling, it's really good to have a good connection, but a good connection costs money. And that's also with the cloud computing. If you want to transfer your data to the cloud, it costs money, it costs resources, it costs time, and therefore also your analysis may be a little bit later in time, or you will get your results a little bit delayed. Talking about these two technologies, you might see there are advantages and disadvantages. My personal feeling is a combination of these two would be the best. So calculating maybe some KPIs, some performance metrics on the edge level with the benefit of having all data available, and then sending maybe the most important KPIs to the cloud so that anybody can access it. But I hope that I can already motivate you a little bit that these two technologies are really, really interesting and are really shaping our future in terms of data analytics and also in terms of industrial projects. And that brings me to our first project, the smart condition monitoring. So here, as a reminder, we are deep diving into a cloud solution. So let's take a look at the customer situation that we are facing. In the industry, unplanned downtimes lead to really, really high performance losses in a production line. And that is not related to any maybe branch or any field of industries. It's everywhere. If you think about car manufacturers, if you think about industrial things, everybody really wants to have the factory to work and not to be stopped. And wouldn't it be nice if we could get value out of the data that a machine is generating and maybe predict that a downtime will happen? This would, of course, decrease the downtimes, decrease the costs, and also decrease the loss for the company. And that's also a statistic that I have found. Smart IoT solutions can help to increase the performance up to 10% just by using the data that is already there. And that's also the thing that we are doing in the smart condition monitoring. To give you a little bit of an overview what's happening there. So let's start at the bottom left side. So here you can see a machine. And a machine, as you know it also from your electrical devices at home, if it is your PC where you're currently sitting in front of, or your refrigerator, the machine, if it is in working mode, behaves a little bit different. It vibrates a little bit, so you can see it on the refrigerator maybe a little bit more if the compressor is starting. And that's the same with machines. And therefore, the smart condition solution works in a way that we are collecting data from the machine, how it is vibrating in a normal mode. We are collecting this data using smart sensors, we are calling it. So they are just mounted on any field of the machine, and they are transferring their data via a Bluetooth protocol to a gateway, and the gateway is sending the data to our cloud solution. So here it is stated MindSphere, that's the Siemens solution for that, but of course it could be any provider like AWS, Microsoft Azure, as I mentioned. Here the MQTT protocol is used, and in the cloud itself, we are trying to determine, is the machine currently performing in a good or maybe in a bad way, so that we need to notify a maintenance worker to please check the machine, please check whether the conveyor line is still okay, or maybe something is stuck in the filler line. And of course, you have seen it also in my CV at the beginning, we are providing solutions for the customer where the customer can also interact with. And therefore, on the right-hand side, we can see some applications, some user interfaces where the customer can, of course, administrate and configure his machines there. Maybe one important aspect here as well. It sounds rather easy. Yeah, please analyze my machine and then please predict me some anomalies or maybe some downtimes. But if we are speaking about industry, it really needs to be a solution that is performing 24/7, that also fulfills quality and security standards. Because I would say as a little bit as a bigger company, you need to guarantee that for the customer. And therefore, we need to take care of every edge case that might come in, also in terms of data quality. And those are the big challenges that we currently have in the industry. To give you a short overview how we are doing the detection of anomalies, let's call it that way. I thought I will deep dive with you a little bit into the data analysis part of smart condition monitoring. So let's take a look at it. First, of course, we design some kind of, we call it the artificial intelligence task. So I will give you a little bit of a detail on how we are doing this anomaly detection on the industrial assets. If you take a look at the picture here at the bottom, you will see here the machine and the sensor as I depicted it before in the graphic. This sensor is giving us a signal, and we are classifying that this is a signal where the customer really says, hey, this signal is a normal one. Do you have a question? I see that you have raised your hand. Should we put the question in between, or should we handle it afterwards?
Let's do it at the end.
Okay. I'm sorry, I'm not sure where to get rid of this notification, but otherwise I will just leave it. Okay, so our sensors are depicting the signal, and our customers are classifying it as, hey, my machine works that way in a normal way. Then we're using artificial intelligence with an autoencoder to generate a reconstructed signal out of it. And we are saying, hey, if the error, the reconstruction error is rather low, everything is working as expected. There does not need to be a maintenance window or anything. Customer, you're good. In case the signal in the second case here, you can see that there is some abnormality at the sensor, and you can see that the signal is shifted a little bit to the right, and also the skewness is different of the curve. And of course, this would be depicted from the autoencoder also in the reconstructed signal, and this would result in a high reconstruction error. And that's the way how we are detecting those anomalies on a machine. Just to give you a quick insight about the hardware specification. So this is a project where we are really doing the end-to-end journey, I like to call it that way. So from hardware development, from hardware mounting to application development with the analytics part. So therefore, I would just like to give you some real-life pictures. So those things are also really mounted at some customer places. For those who are interested in the hardware spec, we do have here those sensors. They are really able to operate, I think, in a huge amount of temperature levels, and the communication protocol of them is Bluetooth. The sensor is sending in 512 samples per 100 seconds, which means a sampling rate of 76.8 milliseconds. So there's a lot of data that we need to analyze. And we are, of course, also collecting the vibration in the 3 different axes, X, Y, and Z. I already mentioned that the cloud data collection is done via MQTT, and worth to mention is here that we have built up a whole solution on AWS to do the actual anomaly detection. So here we are really, how to say, taking advantage of cloud infrastructure providers. And we have done all the implementation for the analytics using Python and of course some well-known libraries that Python comes with in terms of data analysis. So let's see, training of the model. So I have mentioned before that we somehow need to identify how the machine is working in a good way. And of course, we are asking the customer, hey, please give us a time range in which the machine has behaved normally. And then we are doing some pre-processing on the data using a FFT, so fast Fourier transformation, normalize it, of course, and then we would have the data that can go into the autoencoder. And to give you a little bit of a feeling how long this would take for an actual customer, I have put here some numbers. So if we would take into account a data set which contains 1 week of sensor data, so if you remember with the 512 samples, it would mean that the customer needs to wait 15 minutes to have a model trained and already fitted to his data. The inference time then takes only half a second, which is really fast. And some of you might say, well, 15 minutes, that's such a long time. But for our customers, this only needs to be done once. And then, yeah, they do not need to do it again because we are trying to make this training procedure as robust as possible. And therefore 15 minutes are really worth it if you can prevent downtimes using this 15 minutes. And after that, if we have trained a model on how the machine is performing in a normal way, as I mentioned before, we are going to deploy this model. This means it will be activated on the AWS backend, and it will then evaluate the live data continuously and immediately react to some kind of difference in the reconstruction error. And this, of course, will be then notified to the customer, currently SMS, email, whatever. You can also take a look, of course, in the application, in the web app that you can see here in some screenshots. And then hopefully he will be notified about anomalies and hopefully will not have these anomalies happen so that he can do some measures to prevent it. And as this was now quite theoretically, and I hope that I have shared with you also the sound of this video, I have now put here a video in from one piloting customer where we have introduced a smart condition solution, and it might be that some of you know it. It's Coca-Cola Hellenic in Edelstahl, Austria. So I think the sentence that we have seen at the end of the video, turning data into value, is really the main message that I want to give with this project. The data is there. The machine has the vibration data. Let's turn the data into value. Let's analyze them in an appropriate way, and then we can make really great customer benefit out of it. With that, I would like to switch to our edge topic, and I will just take a quick glimpse at the clock. A little bit over half, right?
So according to my clock, we have a few minutes left.
Okay, then I will be quick. So energy efficiency labeling. Let's switch here. So I think if we talk about energy efficiency, most of you know it also from your electronic devices at home. So if you think about buying a refrigerator or a dishwasher at some electrical market, you will see this nice little sticker on it where it states A triple plus, I think till last year now it's A to G. And this is the energy efficiency class. And if you think about that all your electronic devices have such a sticker at home, of course, it would be also of interest for customers or for industrial partners to know how efficient their machines and their factories are currently. For calculating efficiency, one big thing we need to know, you need to know the operational state of a machine. So a machine is most efficient if, of course, all the energy, for instance, that she is using or that the machine is using will be used in a state of producing, because you do not want to put energy in it if the machine is just in a standby mode. And that's all you need to know about energy efficiency. And currently, we do have out there a situation in industry that not all machines are capable of detecting their own state. Sounds like a rather weird problem, but it is really the case. So you, as a machine builder, you do not know, is my machine currently in the standby, in the producing, maybe there's some power up, power down, but you need this information to calculate your efficiency. And therefore, we have used edge computing. So what we have tried to do in this project is we have used one signal, because one signal every machine has, it's the energy consumption. So every machine needs energy to operate. And with this energy consumption signal, we were trying to determine the machine state. And therefore, we used the edge computing technology because of the advantages that I told you before. We are really nearly located. We do have access to all of the data available, and we can do also, let's say, lower level calculations which are sufficient for this use case on the edge device itself. So we are getting the signal, analyzing on this little edge IPC, and there you can see how it looks like. We are retrieving the status using an approach of artificial intelligence or statistics, to be honest here. So we have been using here k-means clustering and the fuzzy C-means clustering to receive the state of a machine. We can calculate, of course, KPIs out of it and provide to our machine factorers some kind of labels to the machine. And of course, this would benefit for our customers because they could also see where are maybe some points of improvement, where can I improve the process of the resources that are generated in my machine. And of course, we can also increase the transparency for our for industrial partners, because before edge computing, you were not able to access the data. To give you a short overview about the architecture of the energy efficiency labeling, I will just quickly jump over that, but we are at the field level where the application is deployed. We do have in the middle the edge device. So this is the industrial PC that I have shown you in the slide before. And this will get the data from some maybe PLCs or from any process unit that you got in your machine. The analysis will be done on the edge device here, and then maybe the results can be put again to the cloud level or to the application that you have deployed. Also, I will give you a short detail about the technologies that we used here. On the edge computing, it's really important to say that we are using Docker here a lot. So everything are containers now, which is a good thing. From a technical point of view, an edge application is really also an end-to-end journey. So we have implemented here a data storage, an MQTT broker, an analytics container, as you can see here with Python. We have, of course, created an own backend and an own frontend, which will then result in the application for the customer. And here I also do have a video available of a use case where we have put the energy efficiency labeling edge computing at the LIT in Linz. And I just realized, I think it is German, but I will show it to you nevertheless. And there we also do have some pilot customers. It is the company Erema, so a recycling company, which are already taking benefit of the solutions of energy management and energy efficiency labeling on edge. So let's take a look at it together.
Energieeffizienz ist für unsere Kunden natürlich ein sehr großes Thema. Das mechanische Recycling umfasst sehr viele Prozessschritte und daher ist es das Ziel unserer Kunden, den Energieverbrauch der einzelnen Komponenten zu minimieren, um so natürlich auch Ressourcen und natürlich auch Kosten zu sparen. Energiemonitoring-Systeme helfen uns als Maschinenbauunternehmen, um die Energieverbräuche der Anlage zu visualisieren, zu analysieren, um so Energieeinsparpotenziale aufzuzeigen, damit wir unseren Prozess und die Maschine optimieren können, ganz im Sinne der Nachhaltigkeit zur Ressourcen-, Energie- und CO2-Einsparung.
Wir als Siemens versuchen, unsere Kunden zu unterstützen, im Speziellen mit unserem Portfolioelement, dem Simatic Energy Manager Pro, die Energie aus einer Anlage zu analysieren. Und mit Analyse ist hier gemeint, Betriebszustände zu erkennen und daraus auch auf die Energieeffizienz rückschließen zu können und dadurch Energie einzusparen. Nicht jede Anlage und nicht jede Maschine, die schon auf der Welt verbaut ist, kennt ihre eigenen Betriebszustände. Deshalb muss künstliche Intelligenz verwendet werden, um diese Zustände automatisiert zu erkennen. Ohne eine automatisierte Zustandserkennung wäre keine Analyse der Energieeffizienz möglich.
In der LIT Factory beschäftigen wir uns neben der Energieoptimierung von einzelnen Prozessen auch mit jener der gesamten Fabrik. In dieser Fabrik haben wir 3 Hallenschiffe, die mit Anlagen unterschiedlichster Hersteller bestückt sind. Und darüber hinaus betrachten wir auch noch die Lüftung, die Klimaanlage und das Heizungssystem der Factory.
So as you can see, energy management really plays a big role for all of our industrial partners, whether on edge or on cloud computing. And with that, I'm already at the wrap up, and I hope that I could give you a little bit of an insight into the 2 fields of edge and cloud computing with at least one customer use case already implemented out there in the world. And maybe to give you just a quick overview at the end, which technologies and knowledge areas are needed to implement such solutions. And as you can see, it's a variety. So we are coming from infrastructure topics on the AWS side to data analytics, could be Python, could be R as a statistical fundamental language. We are working with web technologies like HTML, Angular, Nest.js, CSS. Of course, it is worth to know network insight. So during my degree program, I was like, yeah, not that interested into networks. I think I can admit it now, but you need that afterwards. So be patient with yourself. You need everything you are learning in your degree program. And with that, I want to conclude my talk today. And I wanted to give you one statement on your way or on your career journey. It accompanied me also during my journey, and it is the future depends on what you do today. And as I have already heard in the talks from you guys, you are all doing really great things. So I wanted to encourage you, be motivated, be interested into new things. And I hope that we will maybe see each other again. And we will, of course, hear from you all what you are doing in the future, because you will be doing great things. So thank you for your attention. And if there are any questions, of course, I will be happy to answer them. And thank you again for having us today here.
Okay, thank you very much for this presentation. So I think we have time for 1 or two short questions and also maybe not too long answers in the interest of time. So there was, during the talk, one of our students, I think Fabian Jogel, was raising his hand. So if he's still around or whether...
And when the question is still present?
Yeah, unfortunately, it was not in the chat, so that's why.
I'm sorry for that.
So I cannot repeat the question. So, but since no one, so I see the dean raising her hand.
I play the icebreaker. So, thank you for the presentation. Very interesting presentation. You were mentioning on some slides that you store your data in Amazon WS, and perhaps it's more, yeah, also a strategic question. Wouldn't be Siemens large enough to have its own cloud?
It has. So maybe this was a misunderstanding.
Is it secure enough to go to AWS?
Okay, got your question. Thank you. That was maybe a little bit not covered by my talk. Siemens has its own industrial cloud platform. It's called MindSphere, and there they are providing all the capabilities for customers to get their data to the cloud, store it there, and analyze it there. In the project of smart condition monitoring, we have used AWS because of its computational power, let's call it that way, because of its scalability, because of the resources that we can really dynamically allocate. But the data is stored in the IoT solution of Siemens. So Siemens is big enough to have its own. Thank you for the question.
Thank you. Are there any further questions? So please just raise your hand. It's not necessary to type it into the chat. So maybe let me ask one short question. So since we have also our Dean of Academic Affairs here and also me as a Vice Dean of Academic Affairs. So, and I think at Siemens you have some of our students. So how to say, do they miss some skills? How shall we sharpen our curricula from your point of view?
Okay, so from my point of view, and it's always hard to talk about yourself, I think if you do have the capability to learn new things and also do have the motivation and the interest to learn new things, you can do everything you want. So bioinformatics to the industrial computation, it's a rather wide step. But of course, I think a really big part is data analytics. As I mentioned at the beginning, data is everywhere, and all the projects that I so far was able to participate in, it was relying on data analysis. So if you do have some general know-how on this thing, on data science, I think you're already good to go. And I always say, if you can program in one language, you can also learn the other ones. It may take some time, but if you do have the right mindset, the right way of thinking, you can do that.
Okay, thank you very much. So I think now we can move on to the award ceremonies. So let me share my screen now again. As you already know, it takes a while when I'm doing this. Yes, so maybe first of all, let me say a few things before we hand over to our more or less four ceremonies. So we have the Siemens Awards for Excellence, we have the Bachelor with Honors, we have the Best Poster Award, and then we have to go up in the list again, and then we will know who wins the Distinguished Young Alumn Award. So usually we hand over certificates, checks, and whatsoever to the winners in person at the ceremony. Of course, this is not so easy today, but please trust me, money will be wired, certificates come by email, and so on. And also what we do usually is, of course, to take some nice photos, no, with the distinguished person who hands over the awards. So, of course, also this is, we need to adapt a little bit. So I just would like to ask the awardees to let your camera on until the end of, so to say, your ceremony so that we can take a screenshot. And as I have mentioned, each of the awards will be presented by a distinguished person who will give on the one hand a short background on the award and then introduce the awardees. So that's so to say now summarized the procedure. It's for the upcoming events, and therefore I now proceed with the Siemens Awards for Excellence. And let me introduce Michael Freyny at this point from Siemens, of course, head of digital industries in Austria and Central and Eastern Europe. So he started his professional career at the beginning of the 1990s at Siemens, after having finished his master's studies in electrical engineering at TU Berlin. He held several leading positions in Germany, Thailand, and USA. And I have to stop my share now. And I see Michael Freyny is already here. Welcome. We are very honored to have you here to hand over, so to say, the certificates. And we also would like to ask you to say a few words about the motivation of this award. And the floor is yours. Thanks for being with us tonight.
Thanks, guys. Thanks for having the opportunity. And I think Siemens is very proud to support, those programs from the university here in Vienna. And I think, we are supporting a lot of universities in Austria and other countries and worldwide, because we strongly believe, you asked the question before, how do we get the talent? How do we get the talent ready for industry? It's only if we work together. And I think, that's another step where, we work very close together with you, not only on this award, I think on a couple of projects, which is actually extremely beneficial. But let me also jump back a little bit. I was listening to the end of one of the presentations, and I was, of course, listening to Daniela's presentation. And, it reminded me, as you said, I finished university in Berlin roughly 30 years ago. And, I went back a little bit and I said, well, in those 30 years of my professional career, what are a couple of things that I would love to share with the audience? Because you are all at a certain stage where you now move into a professional career. And I just want to share a couple of things with you. I started in Berlin, in my hometown, with Siemens in R&D for hardware and software. And my boss came after 4 years and said to me, look, Michael, there's a program, you can go to a foreign country, which is an engineers development program. Are you willing to do this, or do you want to be an R&D engineer for the next 30 years? And I quickly, oops. Can you still see me or hear me?
Yes, everything is perfect on our side.
Okay, I have a black screen. Okay, nevertheless, okay, whatever. Nevertheless, I can just say, I quickly made the decision and said, well, while I'm a good hardware software.
Okay, so the problem obviously arrived a bit later on our side. So now let's maybe wait a few. Mr. Freyny is back, at least we can see him. So I think we need to unmute him, probably. Maybe I have the right for doing this. I'm not sure. So, our technicians, maybe they need to give permission. I think I'm not able to do so.
He has the rights.
Okay. Thanks, Peter. So, Mr. Freyny, can you somehow try to unmute? No, we still cannot hear you, unfortunately. At least now the symbol is gone. Maybe say something.
I still look like I'm muted.
Now it's fine.
You're mute. Yeah. We can hear you.
No. Yes, now it should be okay again, at least from the symbol.
Murphy's Law, it seems like.
Yeah, no need to worry. So now it's fine.
Okay, so maybe where you lost me, as I'm saying, you know, you need to make decisions. Where are you competitive in your career? And you know, usually you can identify things where you are competitive, which are easy for you and difficult for others. You know, when you see you can do something easily and others struggle to do this, this is where you're strong at, and play to your strengths. On the other hand side, never forget you need to be passionate about what you do. Because my experience as a leader is, you know, I like people to work with me that are passionate about the topic. So, you know, that's one thing. I had, as you said, the opportunity to work in different countries. I encourage everyone to do that if you have a chance. It is not only beneficial for your professional career, but for you as a person, because cultures are different. You know, the Americans look the same like the Europeans.
Okay, again, we lost Mr. Freyny. That's very unfortunate. Let's wait a few seconds. So
it seems that Michael Heiss is also online from Siemens. So if we really have problems with Mr.
Yes,
I think Mr. Heiss can take over.
This would be one opportunity. I thought about maybe swapping the Bachelor with Honors with the Siemens Award.
Yes, I can unmute myself and I can show myself.
Hilda, good to have you here. Welcome. So I'm just wondering how to communicate this now the best way to Mr. Freyny, but I think it makes sense to now do the Bachelor with Honors first, and then do a second try with the Siemens Award of Excellence. So Hilda, just in case if Mr. Freyny jumps into your session, you maybe can, or we can.
I can chat with him. It's okay.
Yes, exactly, exactly. So Bachelor with Honors. I mean, I think I just give over to you, Hilda. No? So that's.
Thank you. It is great actually to have this epilogue. I think it's really very good and it's very professional. So many recordings and everything. So I think it's very well done. He's back. Maybe he wants to jump in now, or he waits?
Yeah, Mr. Freyny, we just thought about swapping the order a little bit, maybe until the thing is more stable on your side. Is this okay, or shall we give it a last try?
Oh, we cannot hear him. We cannot hear you. Audio is not working. I hope that we will.
So I would say you continue with Bachelor with Honors.
Bachelor with Honors. Yes.
Yeah, let's continue with Bachelor with Honors and then come back to the Siemens Award of Excellence.
Okay, I will. So Bachelor with Honors. My name is Hilda Tellolo, and I like to introduce Bachelor with Honors in our great Epilog event. So because it's a very interesting project that we have and a program that we have. Bachelor Honors is our excellence program of our faculty, and we are really proud of it. And why? Because our faculty have really several great projects to support the ones who need more attention or can make really a good use of additional training and mentoring or alike. So you can see in our website that how many different programs we offer to everyone, to the students in schools, but also to the newcomers. But as faculty of informatics, we saw also the need to support highly talented students of computer science programs because they are really very good and we don't want them to be bored while they are studying Bachelor in our university. And they belong among the top 5 students actually of all students. So they are really very performative and quality-wise and also quantity-wise. They do a lot of courses parallel and with the best grades. We wanted to prove their potential in different challenges, and we offered them different challenges individually. And we have some mentors the mentors are working one-to-one with these students, and we have a group of colleagues and supporting them in this program. And also myself and my colleague Christian Huema, as Dean of Academic Affairs, are really enabling that officially. And in this sense, we engage them also in scientific research while they are studying bachelors, because it's not always usual that you have really dense cooperation with different faculty members in the areas you are interested in. So this is something what we offer in Bachelor with Honors program. And some students want to attend that. It is a dedicated program. So besides all these courses and co-work in different scientific areas, we offer them internship programs, which are not so easy to arrange, considering also the COVID situation, but also some scholarships in order to make them mobile and be part of big companies or other universities. We started 2018 with this program, and we had so far 46 admissions, and 21 of our Bachelor with Honors students have already finished their program successfully. Today, I will introduce you 4 of them and celebrate their success in this program, in this event. They all have something in common. They all have studied software and information engineering as their bachelor degree. And I will start now with, there is no, I think it's alphabetically ordered. Yes, we are always very nice in that. With Andreas Auer. Andreas Auer, maybe you can switch on your camera. Are you here? Yes, hi.
Hi.
Hi. So your mentor was Reinhard Pichler, and you received, I tell you a little bit, I tell to all of them a little bit about their background, and then ask a question in order to make it short, as I see that we are pretty progressed in time today and pretty late. So you received your Matura, in how we say in Austria, in HTL, ATL Neufelden, and you in the field of automation engineering. And after 3.5 years of working in industrial automation, that means you have also experience in industrial area, half of the time in Linz and half in Berlin, you switched the field and started studying computer science in 2017. In 2019, you joined the Bachelor with Honors program, and you focused on intelligent information systems in your program. So our students, for the others, our students can have a dedicated program they design because they are interested in. So they want to know more about this field. And that's why they say they find a mentor and work, in that case with Reinhard Pichler, they could create a program for their program, for their own individual Bachelor with Honors program. And you received your Bachelor of Science degree in 2020. That means at that time you also finished actually Bachelor. Now, this is a precondition in order to finish all the Bachelor with Honors program. So you cannot finish Bachelor with Honors without not finishing the Bachelor degree. And currently you are working on your master thesis. So you studied in the meantime your master program, and then you are working on temporal knowledge graph neural networks. Is that right?
Yeah, exactly. Everything right.
Yes. And this is a great actually program and great choice in our university. Maybe you tell us only one thing. What do you think that it was very excited to you? It is the most interesting and exciting thing in this Bachelor with Honors program.
I guess the most interesting and also I would say that the most effectful thing was unfortunately quite short internship because of COVID and the university in Oxford at Emanuel Salling, which is now here a professor at TU. And it was in that sense very important to me because I also did then after this my bachelor thesis with him about the stuff we did there, and I'm also now currently doing my master thesis with him. So that was a good opportunity to me, and set more or less stones for that what I'm doing now.
Great. So do you want to continue with your PhD on top of that?
Yeah, actually, I'm hopefully at the finish line with my master thesis now, and I'm currently in the process of applying for that stuff and so on, but it's nothing fixed yet.
Okay.
But I probably will go for it.
Good. But this opened you the different perspectives, and then I think we are very glad that our program offers something like that. And congratulations for your Bachelor with Honors.
Thank you.
Thank you for that. So we move on. The next Bachelor with Honors student is who finished actually the program is Adrian Čumurović. Are you here? Maybe you switch on your camera. Yes. Hi.
Hello. Does it work?
Hi. Yeah, it works. We can hear you and we can see you. Great.
Cool.
So, your mentor was Gernot Salzer, and you are originally from Czechia, as a Czech
Republic, yeah.
Czech Republic, yeah. Why is it Czechia in the text? It's interesting. And then you attended the school in Austria since kindergarten. So that means you are in Austria since then. And you graduated in Borg, Mistelbach. And you decided to study computer science at our university. And you enjoyed, obviously, logic and theoretical computer science. So you found out that part of you. And then you enrolled in the Logic and Computation Master Program, and then after finishing the Software and Information Engineering Bachelor. So that means, I don't know whether you finished already your master degrees?
No.
No,
this is technically my first semester.
Oh, okay. So I can imagine, because you didn't finish, so it's not so long that you finished your actually bachelor.
November.
Yeah, it's very good. Yeah, you managed to join us now in this event. This is good. And I think you had also the internship in ETH Zurich. Is it right? Yeah. And now you are planning to be involved working on research project and research internship in the summer. Is it right too? Okay.
Yeah.
So maybe you can tell us, this is great to hear and to see that you have done so many things. Can you tell us a little bit what was very interesting in ETH Zurich, or what is exciting about it?
Well, I mean, it was like really cool to be there at like in this research group and just like see how the people work together and what happens. Because even if I work like a tutor, I don't have any insights on what actually goes on in like the offices and stuff. And now we are just sitting there trying to solve some problem and listening to them talking to each other at lunch about conferences and whatnot. So that was like you have so much more insight just like by a random statement they make about reviewers or something. It just, I don't know, it's like I can read like some, I don't know, Reddit post about how universities work, but it will not really give me any knowledge.
Experiencing is a different thing, isn't it? So you feel it how it is, and it is very exciting also. Of course, if you have always success. So, if you are not very successful.
Yeah, I've also like heard like how much pressure they face, and that was also interesting.
Yes, this is good actually to have both sides of the coin. So this is something which is difficult, and if you manage it's good, but if it's not, then you manage it anyhow. So I think this is how the scientific life is. So it's great, and I congratulate you to finish that you have finished your Bachelor with Honors. Congratulations.
Thank you.
So, and I move to the third Bachelor with Honors student, and this is Alexander Palzberger. Are you here? Can you switch on your video, please? Camera?
Yes.
Hi. Hi. Your mentor was Georg Gottlob, and you come actually, you grown up in Pichel. This is by Wels in Upper Austria. And you actually you started studying clarinet at Anton Bruckner University in Linz and also in Kunstuni Graz during the upper school. So they are these music schools. And approaching graduation, you met more motivation in natural sciences. I don't know why, because music is actually great, but it doesn't matter. It's also a good choice that you decided to do natural sciences, and in particular, computer science was your interest. And then you devoted yourself then to the studies at TU at our university, and you got also internship at Oxford University and Max Planck Institute Saarbrücken. And then you found out that obviously this interests you, and this is something that you want to do more than clarinet. Clarinet is a really good instrument. It's pity, maybe you play still clarinet. Are you playing still clarinet? Yes, good. It's good for your back also, you know, how you play. So it's a good balance between computer work and yeah. And in the context of your Bachelor with Honors program, because Gottlob was your mentor, you focused on the subject distributed reasoning in knowledge graphs. And then you did it with VMware, supervised by Emanuel Salinger. So we hear now again the same name. And you combined also your Erasmus semester in Sicily. And you initialized your master thesis on continual machine learning on the edge. And then you have the supervisors, Professor Villari and Professor Brandic. So I think these are very exciting things. And obviously you are a lot of times abroad. Why is it important for you to be mobile and to have experiences outside our university?
I would say the experiences also at TU Vienna were quite intense, so I have not the feeling that I missed anything at TU Vienna, I have to say. And
good answer. But still, what is exciting abroad?
I think it's just also a motivation that I guess many people have at my age. It's a good point in life where you can actually be so mobile and travel abroad. And this is one of the reasons I really enjoyed the Bachelor with Honors program, because it gave me the possibility to do such great internships, especially abroad. You can do great internships also in Austria, but to have really good opportunities abroad is not so easy, and is also a difficult process sometimes. And yes, that's definitely an advantage.
And what do you plan after your master thesis? Do you want to continue with your PhD, or are you going to Sicily to continue?
Sicily is really charming, yes. PhD, I have to say honestly, I have not excluded it yet. I definitely want to have, since I got a lot of experience in the academic research now, I want to get some experience in the industrial sector. So I know that after the thesis, I will start working, but not until I go into pension. I don't know yet. But it's still up to decide for me.
Yes, great. You have enough time, all the time you need. Great, congratulations. Well done. So, and now the last colleague to celebrate with is Christoph Günther. Christoph, are you here? Please switch on. Yes. Hi. So your mentor is Matteo Maffei, and this is the first text I see in the text. That's why I'm saying it always, but I don't know what I'm saying. I can do it also later. So no, I have done it by all of you. And you moved to Vienna from Innsbruck. And you studied software and information engineering as bachelor degree at our university. And then you started to develop the interest to cryptography, security, and formal methods. Is that right?
Yes, exactly.
And that's why you're mentor, obviously. We have so many brilliant colleagues in different areas. So you can have any interest in computer science. We have our faculty members to support all of you. And after 2 years of study, you were accepted to the Bachelor with Honors program. And then you finished your bachelor's degree in October 2020. and then also finished in September 2021 the Bachelor's with Honors program. Now, you are actually not at our university anymore. I'm reading it now, and you are first year PhD student at IST Austria.
Yep.
So, obvious question. Why didn't you continue studying PhD at our university and move to IST Austria?
Well, through my Bachelor with Honors, it was heavily suggested to me that I take a course by a professor from IST that taught at TU Wien, and it was in cryptography. And like at the end of my bachelor's, I kind of saw that I either want to do formal methods or more like cryptography, but not this intersection anymore. And then I heard about IST Austria also in the Bachelor with Honors meetings. For example, from Professor Schmidt. And I thought that might actually be quite a nice thing that I can try out the different areas and then decide during my PhD what I want to do. And that's why I applied there, and now I'm here, and I think I'm going to do cryptography.
Great, great. Very good choice. And I think we are very proud of that, and congratulations for your work.
Thank you.
So thank you all to be part of this program, and thank you all to appreciate our offer and then really make the best use of it. And all the best to you, whether you stay at our university, whether you go to the industrial settings and then have some experiences there in another country or in Austria, or you study with in our university PhD. So thank you a lot. So Stefan, I'm done.
Thank you, Hilda. Thank you very much. Congratulations to all Bachelor with Honors students. So great achievements, of course. So I would have a slide summarizing and to see the names on the screen, but we also wanted to do this photo. I hope this worked in the meantime somehow. And we now give it, when we do a second try for the Siemens Award of Excellence, we now have even a fallback solution installed. So I just stop share again. And I now asked either Michael Freyny or Michael Heiss to take over.
Okay, I give it a second shot.
Ah, good. Okay.
It's like you're always in life, you know, you hopefully have a second shot.
Yes.
So I don't know what happened, but you know, sometimes it's Murphy's Law. I could listen to everything quite fine. I'm not sure, you know, whether it has then to do when I switch on something or things like that. Okay, nevertheless. Hey, let's cut it short and simple. And I understand you couldn't really hear what I was saying. First of all, I definitely have to say in the name of Siemens, we are really happy to support this program of the University TU Vienna. I think we have a long cooperation. I think this is the 10th year, at least 10th year where we support the program. And we have other areas where we work together. As we say, and as I say, it's very important for us to build the bridge between, you know, the education and the real business world, and you know, get students and get everybody as well as possible prepared for business life. And, you know, I was actually listening to what many people were saying, and I was put back a little bit, you know, 30 years when I finished, as you said, in TU Berlin. I finished my studies, and, you know, I went to get on my first job for Siemens in R&D and software and hardware. And I probably just want to share just really quickly a couple of things that, you know, were decisive in my business career. And, you know, the first one is, as I said, I started in hardware and software development. And, you know, after a couple of years, my boss came and said, well, you know, you can take part in an engineering development program, which will be overseas, or you will be a software engineer for the next 30 years. And while I was a good software engineer, I wasn't a great one. And I made the decision for myself, am I really competitive in the long run? And I defined for myself, you know, if you're good, but then you're great, let's move and try to do something else. Try to find the area where you are really good at, and where you're really competitive as a person. And I think this is also the advice I would give everyone, start, but, check and see, what's easy for you and what's difficult for others is usually your strengths, and utilize and build on your strengths. That will always give you success. The second thing is, you saw that I spent time overseas, and actually I had the privilege to spend time on 4 continents. I'm of course working in Germany, now Austria, in Europe. I spent time in the US, I spent time in Thailand, and I spent time in Australia. So, and not only for business purpose, but for each individual, I think it's super beneficial if you have the opportunity to go somewhere abroad. Have an open mindset, look at cultures, things are done differently. You will appreciate some things that you have. For example, if you're in Vienna, and they will be different in other countries, and you will learn what you really appreciate. But on the other hand side, you will really learn from other cultures what they do very well. And lastly, I want to say that there's one thing that always keep in mind. When you work in a business world, and I start with an example from actually Frederick Malik, which is a good book that I read, and was something like my business Bible, to be honest. You read books and you identify some things are good and some things suit you very well. And this book actually, he as an author was resonating with me very well. And in his book, he had one great example. He went to a job site and he was asking bricklayers, why do you work here? So he was asking the first one responds, because I want to make good money. He goes to the next one and saying, well, why are you working here? And then he's saying, well, I want to be the best bricklayer in the world. And then he goes further and he's asking the third one, and the third one stops a little bit and saying, well, I want to build a cathedral. And, keep this in mind. When you are in a leadership position, you need a lot of people that have this mindset. Our world is so complex and so diverse that your team needs to focus on building something together. You need to be good at what you do, but you never should lose the eyesight of actually what the whole purpose of those things are. And I just wanted to share, those couple of things which have been decisive in my career and which always, have been some guidance from my side. And I hope some of those resonate with you. And when you progress in your professional career, maybe you will think of some of those, or you come at a decisive moment. Okay, but now we come to the honors and to the program and to the awards. And actually the first one that I have on and giving the award to, virtually of course, is Lisa. Lisa first. She's a 23-year-old student. Started in 2017. In particular, artificial intelligence and training of machine learning. I think you probably could resonate with what Daniela was presenting. And you have an interesting topic, which honestly I have a question almost to. It's privacy preserving machine learning. What is it supposed to be?
Well, in privacy preserving machine learning, what we're trying to achieve is to keep the data safe from attackers, but also to keep the models safe from attackers, so that, for example, companies could sell their models, but make sure that only the people who are actually allowed to use the model do use the model. So that's one use case of privacy preserving machine learning.
Perfect, because we very often have the discussion with our clients and saying who owns the data, right? I mean, they buy the machines with our equipment. We do some analysis on the data, and always there's a conversation. Who owns the data and who's what. Great, and congratulations to the award.
Thank you very much.
The next award goes to Sonja Gerstenmeier. She's also studying in informatics, and she did already in school a so-called computer Führerschein. So it's like a driver license for computing. I found that really interesting, a great topic. And she especially is focusing on design and augmented reality. Also a topic which is, in our industry getting more and more important. Imagine you're doing remote condition monitoring and things like that. We all know about the Google glasses and things like that, which are so good in some areas that you have really a focused and a really technologist sitting in one region or in one city, and having somebody else that he can guide based on virtual reality and augmented reality on how to repair certain complex things. So Sonja, maybe you say a couple of things of what you actually do.
I don't do a lot right now besides studying. So, well, this semester I actually wrote a little paper report about augmented reality and uses and challenges. And I actually also talked about remote work and collaboration. That was really cool.
I think, we really realized it during COVID, as, you can imagine, you weren't allowed to travel. In our industry, you have a lot of, service work. How do you utilize that with people that are in place and, experts are sitting somewhere else? And I think, those kind of things then are really helping industry to do the task even in difficult situations.
Mm-hmm. Yeah.
So congratulations.
Thank you.
The next one I have is Sonja Schober. She's also studying a Bachelor of Software Information Engineering, and she's focusing on algorithms and optimization of logics. Maybe Sophia, you can say something about what you mean with optimization of logics. That sounds interesting to me.
I'm not really optimizing logics. I think what I wrote was heuristic optimization. So logics and the optimization part that I focus on are two different parts. They're not connected.
Okay. So then maybe I just read it. I read it wrongly. But what are you optimizing then?
So, for example, different combinatorial optimization problems.
Okay, great.
So stuff like the TSP, for example, something that probably every computer scientist knows.
And when you talk about algorithms, what's your focus on algorithms? What type of algorithms?
Do you mean in my Bachelor with Honors? What
Yes.
I wrote? Yeah, just algorithmics in general. I'm just starting out with my Bachelor with Honors, so I haven't put any focus on that yet. But I'm really interested in, for example, FTP algorithms, if you have heard about that. That means like very hard problems that can be solved more efficiently if you add certain restrictions to that problem. So that's something I'm really interested in.
So Sophia, congratulations. Congratulations to get the award and all the hard work that you're putting in. The next one is Christina Tüchler. She's also studying media informatics and visual computing. You're focusing always on new challenges and gain new experiences. Maybe you can share with us what are the latest challenges that you're focusing on?
My next challenge is my bachelor thesis. I will start with it in February, and I'm looking forward to it. And yeah.
So, do you have already a topic?
Yeah, it's about image processing. Yeah.
Oh, great. So I wish you all the best, and also congratulations to the award.
Thank you very much.
Next one is Jasmine Hader. She's also working in software development, and I found something very interesting in this reference, saying you're not in the details, but you prefer to see the whole spectrum. What do you mean by that?
It was actually regarding diversity topics, but I'm just interested in many things. So also when I went back to study at the university, because I already have completed a studies in mechatronics, but now I'm studying informatics. And I'm also very interested in biomedical engineering. So maybe after my informatics master, I will start right away with biomedical engineering. So.
Wow. So you're really building a very interesting portfolio then for yourself.
Yeah.
So
I just can't decide what to focus on because everything is so interesting. Yeah.
Great. Fantastic. Fantastic if you can do this. And, once again, congratulations to the award and all the hard work that you have put in. And I wish you all the best.
Thanks.
The next one is Theresa Müller. She is 25 years old, and she was actually raised in Bavaria. You know, a time where I also spent in Bavaria. You know, I spent some time in Nuremberg. I don't know where you have been in Bavaria, but you are also in the field of computer science and software engineering. And yeah, what are you doing there?
I'm actually working as a software engineer for a company based in Vienna. And it's mainly in the social insurance area, but I still have to do my master thesis, so I'm currently looking for a suitable topic right now.
Maybe to the related subject that you're already working in, right?
Maybe. I have no idea at the moment what it will be, but we'll see in a few weeks, hopefully.
I keep my fingers crossed.
Thanks.
Once again, congratulations and good luck.
Thank you so much. Okay.
The next one is that you know we want to honor and give the award to is Rafaela Pichler. And Rafaela, you know, we have something in common. I see that you have spent time in Atlanta in USA. I spent actually 3 years in the US, working in the US. It was a fantastic time. I can tell you one thing. When we came back, you know, I'm married. I have one daughter. She's, by the way, born in Nuremberg. My wife is from Hamburg, so we are also something like a diverse family. I always wanted to go back to Atlanta. My wife wanted to go to Hamburg, and my daughter wanted to stay in Nuremberg. You know, so we after the US time, we had a quite interesting part. But you know, maybe you can share with us what you think about Atlanta and if you really liked it or not. And you are actually specialized on human-centered computing, and maybe you can say a couple of things about that.
Okay, yeah, well, thank you. First, about Atlanta, I really loved this experience. I was traveling nearly every weekend, and every spare time I had tried to do new stuff. So yeah, Atlanta is really big. Maybe a little bit too big for me to live there, but I had really a cool time there. And about my master studies, I'm nearly done now, so only my master thesis left. And I think the important things I can also remember about my studies were the journey from just having an idea to a full prototype and the final product. So this is something we really learned a lot about doing user research, assistive systems, what to care about. Yeah, so I hope I answered your questions.
Fantastic. So once again, congratulations to winning the award, and good luck to finalize your thesis. Okay.
Thank you.
Last but not least, you know, we have the saying is Timea tot. Timea, you are actually born in Bucharest. That's you know, a city I haven't been to. I have been to so many cities in the world, but actually I haven't been there. So definitely something on my list to visit in the next couple of actually months. And your master thesis is on series analysis and machine learning. Maybe you can say a couple of words about that.
Like I'm already just in the first stage of my master thesis. So the plan was to work with time series classification, but plans changed because of data availability. So I'm still at the point where I'm thinking about to stay with time series or to change to classical machine learning. And yeah, so that's where am I right now.
Okay, fantastic. So once again, congratulations to the award, and good luck with your master thesis.
Thank you.
And once again, I want to thank every one of you. And I have to confess one thing, you know, the stuff that you talk about, you know, and I was listening, I have no clue. You know, I really don't understand the details, and you're so much advanced in a couple of those things. I really appreciate what you do and the knowledge that you have and this abstract thinking about data and analyzing data is something that it's definitely my strengths, but it looks like it's your strengths, and I can just say there's so much demand for those kind of things in the industry, and it's just growing, and you really made a good choice in selecting those kind of things, and I think you will have great careers going forward if you stay on target, and as I'm saying, but never lose a passion. You need to be passionate what you do, and once you're passionate, you will be really good at it. So good luck to all of you, and thank you, and it's an honor for us and for me actually to speak to you, and I wish you all the best.
Okay, thank you very much. So we now also managed this award ceremony in a very nice way. I have to say congratulations to the 8 winners also from my side. I just wanted, I wanted to add here now, and I wanted to also for a summary have this slide now here. I just wanted to add that the Siemens Awards for Excellence comes with €1,000, and that the students are honored for their, so these are the best students of the year, and they are honored for their outstanding achievements in their studies. So it's not about a bachelor thesis or a master thesis, but about the studies themselves and the grades. So congratulations again. I will now continue. We have 2 more things left. So let me see. Oh, no, this is not what I want to have here. I think we now continue with the Best Poster Award, and this will be presented by the chair of the jury, by Margrit Gelauts. And yeah, I think I just give over to Margrit now.
Okay, thank you, Stefan. Yeah, now it's my pleasure to announce the Best Poster Award. And first of all, I would like to mention that, as some of you may know, there was a nomination. A few posters were nominated by the supervisors, depending on the research units. And then there was an online voting, whereas the faculty staff was allowed to cast their vote. And as a particular thing this time, I would like to mention that, so we had 5 posters nominated, and it was probably the first time in our faculty's history that all 5 nominees, just by chance, they happened to be females. So now the faculty had the difficult task to decide among 5 posters that were all really excellently prepared. Nevertheless, the decision turned out quite clear with a vote of over 40% in favor of the winner. And now the winner of this year's poster award is Tamara Drux. She is supervised by Nisret Muslio, and the title of the poster, as you can see here, is Representation Learning for Variable-Sized Multiple Sequence Alignments. And before officially congratulating, I would like to say a few more words about the poster. So as you can see here, the poster deals with the topic at the interface of computer science, machine learning, and biology. And I guess that one of the reasons for this success was that the poster manages to explain the problem statement, the relations to the involved disciplines, and also the lessons learned in a highly instructive and very appealing way. So congratulations to Mrs. Drux on this success.
Well, thank you very much, and also thank you to everyone who voted for the poster and appreciated it, of course. Thanks.
So I guess, Stefan, are you...
Yeah, thank you. I just want to now, I will hand over to you, Margaret, in a second again. So here's just again the list of our candidates. Once again, congratulations to all. And Margaret, I think you will say now also a few words how you came to the decision. And I will stop share for a moment so that we have you on the screen.
Okay. So as all of us have seen today, again, similar to the poster award, the jury really had a difficult task to make up their mind and come to a final decision. And I would like to explain that our judgment, it was based on both on the written thesis and also, of course, on the presentations we have seen today. And now the winner of this year's Distinguished Young Alumn Award is Sebastian Matzer with his work on homomorphic encrypted volume rendering. And before well, congratulations, but still before officially congratulating, I would still like to say a few more words on the jury's decision. So the diploma thesis, in the jury's opinion, presents a new idea, and it opens up the possibility for secure and exciting possibility for secure rendering in 3D space. The value of the thesis, as we've heard, has also been confirmed by publication. And the jury found the talk very appealing. The problem was explained in a way that's accessible to a broad audience. And finally, the thesis also appears highly relevant for the specific application domain of medical imaging. So congratulations to Mr. Matzer again.
Thank you very much. I'm really happy.
Yeah, congratulations also from my side. Margaret, do you want to add something? Sorry.
No, I'm not sure if you were going to explain something about the how the handover of the.
Yes, so maybe I did this already at the very beginning, but let me mention this again. Also, let me first also add that all 4 candidates will receive a certificate for being nominated here, so that they that they have something at hand, and the money will be wired to the candidate or to the winner, of course. Yeah. And I think I'm now asked also that all 4 candidates plus the winner of the base poster award should still have their cameras on together with me and Margaret, so that we can have another photos. Making these photos is now also a different thing again. And yes, I think now this has been sufficient time for the photographer, so to say. All right, I think this brings us finally to an end here. I hope, or we hope, that you are now convinced that not only computers have learned about us, but that our alumni have learned a lot about computers, computer science, and informatics. I think we have seen a very interesting range of topics once again here. Let me, to conclude, just say once again, thank you very much to all the speakers, to all people who have been involved, be it in the jury, in the commission, be it in the award ceremonies, be it our invited speaker. So it was great to have you all here for this Epilog number 33. Finally, let me also say a big thank you to the communications team of the faculty, who do have a lot of work in preparing this event, and without them it would not be possible to do it that way we do it here. Okay, thank you very much again for attending. All the best for our alums for their future careers, and good night from my side. Bye-bye.
Bye-bye.